Hello again. So today we are starting our new unit on ratios and proportions, and this is a foldable where we find the constant of proportionality from a graph, from an equation, and from a table. Now these notes are very important. We're going to take them today, and then for your remote day, there will be a Google form, and all the answers are on this foldable right here that you're going to do. So this is the back of the foldable, which is kind of why it looks funky. So if you're doing this digitally, you don't really get to do the folding part. I should print it out, but Cami is fine. So if we scroll down, we're going to start with the constant of proportionality, which would be up here in the top left-hand corner. And feel free today to use the text box tool, or you can draw the words, up to you. I think the text box tool will help for all the fill in the blanks. All right, and I'm feeling purpley. Okay, here we go. So the constant of proportionality is the constant ratio of y to x. Every time it's y to x, y to x, y, because I said so. So don't mix those variables up. It's always the ratio of y to x. And it'll make a little bit more sense as we go through with a few different ways. Like in our table, we have our y values, then our x values. When we have our graph, we have our y-axis, which is what we'll be looking at, and then our x-axis. But at this point, it's kind of just variables, because we're like, what is that? So it's always a ratio. And we learned Monday, if you did Monday's activity, that a ratio is a comparison of two numbers. And you can use the word two, you can use the colon, you can use a fraction bar. And I'm going to more commonly use a fraction bar. That way it kind of stays consistent. And we've used those before. They're division signs, they're ratios, they're fractions. It's all the same thing. But in this case, constant means at the same rate. So something is continually happening at the same rate. Like if you were driving your car, well, I know most of you don't drive a car, but if you were on cruise control, you stay at a constant rate the whole time. That's the example I have right now. I'll think of a better one. This is represented, now here's where I find it funny. Constant starts with the letter C, but the letter that represents our constant of proportionality is not a C. That letter is a K. So I always kind of think it's funny that maybe somebody spelled it wrong. Constant with a K, maybe like a constant. No, C was already used for circumference of a circle, so they had to pick a different letter for constant of proportionality. So K, if you see K, it's our constant of proportionality. It kind of sounds close, but they're different letters. So watch out for the spelling errors that might occur. When we see it algebraically with our variables, we have our K is equal to our ratio of y to x. So our ratio of y to x. Now I'm going to draw this because I want to draw it like a fraction. You could type it with the word. You could type it with the colon. I'm going to show you as the fraction. So we have K is equal to our ratio of y to x. So it's always going to be y first, then x, which is different from our ordered pairs where we put x first, then y. It's going to get a little weird. That's why we have our notes. You can always look back at this, always look at it, see, okay, the y is first, then the x. All right. These numbers can be a fraction. It can be decimal. And it can be an integer, our positive whole numbers, negative whole numbers, and zero. We can have fractions and fractions. We saw that with our complex fractions. We know how to work with those. Don't worry. Same thing with decimals. That's when we deal with money. Like when you buy candy bars every day, it's the same price. So it's a constant rate. There we go. That was a better example. I hope you're buying candy bars every day. It's a lot of candy. Okay, I'm getting distracted. Here we go. So our constant of proportionality, if the relationship is not proportional, then there is no constant of proportionality. Not everything in life is moving at a constant rate. Things change rapidly. So keep that in mind. So a lot of what we're going to be asking is it proportional or is it not proportional? So basically, does it have a constant of proportionality or not? That's kind of the idea. So this is what constant of proportionality is. We're going to now make a ratio. We're going to do it from a table. So these are from tables. When we find our constant of proportionality from a table, we make a ratio of y to x. Oh, look, that's the same ratio from above, just like this one. But this one has the word 2. This one has the fraction bar. Could use the colon. For, I don't know if I have enough room over here, so I'm going to just put it over here. Does that sound okay? All ordered pairs. All of them. So you make a ratio of y to x for every single ordered pair. Every single one of them. If we look at this table, there's 1, 2, 3, 4, 5. There's 5 ordered pairs, so we'll be doing that for each of them. We're going to make a ratio for all 5 of those. Now, it sounds like a lot of work. Oh no, this is easy. This is easy. Simplify. The only exception, because we know this number is weird. Weird things happen. Because this number is neither negative nor positive. It has some interesting rules when we multiply and divide with the 0, because sometimes you can't divide by 0, which is why we have this exception here. We do not make a ratio when x is equal to 0. Why? Well, if you want to know, we can't divide by 0. Some of you are like, what do you mean division? We haven't done division yet. Look. Remember this? That is division. So if we divide and the denominator is a 0, we can't do it. So that part won't count when we look at these. Then we just check, are all the ratios the same? If they are, it's proportional. If they are different ratios, then they're not proportional. And we'll look at what that means in just a moment, because once you get the hang of that, it's very easy. So our k is equal to the ratio of y to x in simplest form. Now, what does that mean? Well, when we get our fraction, whoa, I spelled simplest wrong. There we go. When we get that fraction, y to x, right? If we have our fraction, what do we do with fractions? We simplify them. So even with ratios, once we get that constant of proportionality, we simplify it. All right, so if we do this first one, this is going to be very, very easy. The first thing you're going to want is a calculator. So let's see if I can get a calculator going on here. I told you in this class we're using calculators a lot. This is a great time to use your calculator. So here's what we're going to do, is we're going to make ratios, also looks like fractions, also division problems of all of our ordered pairs. So if we look at this is an ordered pair, this is an ordered pair, this is an ordered pair, and whoa, my line's got a little out of control. Ordered pair. Now, why did I include this first one? Oh yeah, because there's a 0 for x. So we're just going to pretend that one doesn't exist because we can't divide by 0. We just can't do it. So all we're going to do is set up our ratios as y divided by x. So we're going to take our y divided by x. So we're going to do, I'll write it over here to the left. We're just going to do 3 divided by 1. Where did the 3 come from? Here, our y. Where did the 1 come from? 1, our x. So it's our y divided by x. What is 3 divided by 1? Well, if you don't know from the top of your head, which I hope you do, you can always do 3 divided by 1. Oh, it's 3. Okay, cool. I'm going to write that over here to the right. So then here we have 6 divided by 2. That should also be mental math. But if not, we have 6 divided by 2. Oh, look, 3. So we do our next one. Y, which is 9, divided by 3. Okay, I hope you can do that one mental math. If not, what do you think it'll be? 3. And then we do our next one. Our y is 12 divided by 4. Okay, 12 divided by 4 is 3. Notice they're the same. We talked about that. If all the ratios are the same, it's proportional. We have a constant rate. We have a constant of proportionality. It's moving by threes. 3 is our constant of proportionality. So our k is 3. Was it proportional or not proportional? It was proportional. Easy. All right, let's look at the next one here. Now again, we have a 0 for x, so we're going to skip that one. We have this ordered pair. Oh my goodness, isn't that the same as that ordered pair? So if we do 3 divided by 1, we're still going to get 3. Sweet. Okay, and we have this one, this one, this one. Why am I putting the parentheses and commas? Just to show you they're ordered pairs. Do we need to put that? Nah. I've already done most of them. I'll just leave it for this one. I won't do it on the next one. How about that? Okay, so then we have our y value, 5, divided by 2. Now this one gets tricky because that one you might be like, well, that doesn't divide. Well, it does. We just get a decimal. So we do 5 divided by 2. Remember, decimals are okay. Oh, 2.5. Okay, we write 2.5, and some of you are already starting to see our answer, but let's finish it off here. Our y is 7 divided by 3. So we look at what is 7 divided by 3. That is 2 and 3/10 repeating. That is a repeating decimal, and we now know how to write that. 2 and 3/10 repeating. Good to go. And then we have 9/4. So we're going to have 9 divided by 4, which is 2.25. For our 9 divided by 4. Ooh, is that proportional or not proportional? Are any of those the same? None of them. And we could have known back here when this second one wasn't a 3. They're not going to be the same. So even if one is different, it's not proportional. So that one's not proportional. So then if it's not proportional, we don't have a constant rate. We don't have the same number that they're dividing by. So we just don't have one of those. That's not applicable. No solution. We don't have one. I'm just going to put not applicable, NA. We don't have one. You could put, well, I don't want to put none because that kind of implies 0. Yeah. All right, so our next one, don't get scared with a negative and a negative. We know how to divide with negatives. So if we have 3 divided by 2, and those are both negative, those are same signs, positive. It's going to be positive. All we have to do is 3 divided by 2, which is going to give us a decimal of 1.5. All right, let's write it. 1.5, good to go. Our next one, we have 6 divided by 4, a ratio of 6 to 4. So if we do 6 divided by 4, ooh, 1.5. This is looking good. Okay, actually, I'm going to move my calculator over here. There, now we can see a little better. So then we're going to have our 12 divided by 8. Okay, so we do 12 divided by 8. Oh, 1.5. Ooh, it's looking good. But we got to check them all because even one of these not being the same number would make it wrong. 18 divided by 12. 1.5. I feel it'd be like an SBAC question if just this last one was wrong. 24 divided by 16. What do we get? 1.5. Look at that. They're all the same. Proportional. And what is our constant of proportionality? The number we kept getting as our answer, 1.5. Don't worry, decimals are just fine. And we can do the same for our next one. And we can divide y by x. So we can have a negative 2 divided by a negative 1. Those are same signs, positive. And 2 divided by 1 is 2. Awesome. Well, remember the zeros. Okay, moving on. The next one, we have 2 divided by 1. 2 divided by 1 is 2. Good. And then we have 4 divided by 2. Ooh, that's 2. All right, we had to get 4 divided by 2. 9 divided by 3. Oh no. Look at that. That last one, 9 divided by 3 is 3. No, It's not proportional. It's not applicable. We don't have one of those. Because that 3, 9 divided by 3 is 3. No. That's okay. We just put non-proportional. So it's from a table. Now the graphs are pretty easy. And most of us are visual learners, I feel. So this one is usually students' favorites. It goes the quickest. So there's 2 things that a graph must be. It must be linear. What does that mean? Straight line. I'm going to put that in parentheses. Technically, they only need us to write linear, but I want to make sure you know linear means it's a straight line. Linear, line. You see the word line and the word linear? So linear. And it must pass through the origin. Now, it may have been a while since you heard the word origin, but that origin is represented by the coordinates, and I'm going to write it as the ordered pair with 0, 0. So that's right in the middle, right where the 2 axes cross, right in that center where we start graphing on a coordinate plane, right there, right there, right there, right there. Okay. So from here, our constant of proportionality is the ratio of y to x for any ordered pair. You can take any ordered pair you want that's on the line and do the same thing like we did for the table and divide each and every one of those. That's kind of a lot. So all we have to do for graphs is check whether it's a linear line, it's a straight line, and it passes through the origin. It goes through 0, 0. If it's those 2 things, it's proportional. If not, no. The ratio must be in simplest form. Simplest form. Okay, so the best way to do that, I'm going to be honest, find when x is 1. And I'll show you what that means. So that's in parentheses. Okay, here we go. So this line, is it a straight line? Yes. Does it go through 0, 0? Yes. If we look right there, see how it crosses the center point and it's a straight line? So that means it is proportional. Wonderful. Now, what do I mean when our x is 1? Well, if we look at our x-axis where 1 is and look at where it crosses, it crosses at 2. So there is our constant of proportionality, because every time we're going to go up 2 over 1, up 2 over 1. I'm getting into slope. That's 8th grade. Okay. Bring it back. Just wherever the x is 1, look up. There it is. There's our answer. Next one. Is that a straight line? No. So right then and there, we know it's not proportional. It does go through the origin right there, but it's not a straight line. It has to be both. Means we don't have one of these. Not applicable. All right, this one. Ooh, it's a straight line. Does it go through this point 0, 0 right here? No. One is not proportional either. Not applicable. Ooh, this is a straight line. It has a negative slope, if you were wondering. We don't even know that slope. Not yet. And then we have 0, 0. Good to go. It crosses through 0, 0. It is proportional. So wherever 1 is, oh, this time we're going down. That's a negative 1. There we go. All right, proportional equations. These ones are pretty easy. Must be in the format y equals kx. There's our equation. Look, our k, our constant of proportionality, is right there next to the x. That'll be helpful later. Where k is the, well, that stands for the constant of proportionality. Now, this one's the easiest one to find that constant of proportionality number. This one's the easiest one to tell whether it's proportional or not. This one's easiest to find the number. All right, so k is equal to, k is the coefficient of x. What that word coefficient means, if I can spell it correctly, there we go, is the number that's being multiplied by x. That's it, the number being multiplied by x. So here we go. If we look here, is it in that form? Y equals kx. Yes, it is. It's in that form. It's proportional. So our k is right next to the x. It's 10. Easy. This one, oh look, y equals kx, good, and this, let me not circle it, I guess. Circle proportional, and this is our constant of proportionality, 3.2. Ta-da! Ooh, this one, we have y equals 3x plus 4. That is slip-intercept form, but not proportional. We don't want any extras over here. Why is it not proportional? Because of this. We don't want any numbers being added or subtracted to it. So we do not have a constant of proportionality. We do have a slope, but not a constant of proportionality. Next one, y equals kx. Oh, good to go. There it is. It's a fraction. So our k is 5/3. And it is proportional. Don't worry, fractions are numbers too. This one, whoa. Whoa, we got a 7, we got a minus, we got an x, we got a squared. Definitely not proportional. This one, y equals kx. Oh, look, there we go. It's in the form, good to go, and our k is -9. All right, save these notes because they will come in handy, and I will see you hopefully next class.